what I were to tell you, there were millions upon millions of tiny, tiny bacteria on your skin right now. You probably just squirmed in your seat and telling yourself, I need to wash my hands right now. However, you might be doing yourself not the best solid. In doing so, you're increasing your chance of acquiring an infection that may not be treatable with antibiotics. And since our medicine has advanced, so has the bacteria that causes infection, leading to us to not be able to do anything. However, there is a little anti-hero that can help us outsmart these drug-resistant bacteria, and that's the bacteriophage, or its deadliest organism. Obviously, bacteriophages are microscopic and they interact with bacteria, which falls in my realm of interest, microbiology. My name is Gabriel Sullivan-Brugger, and I am studying microbiology at the University of Georgia and pursuing a master's degree in public health with emphasis on epidemiology. From what I just said, it sounds like bacteria are in. On the other hand, it's not. Only 2% of the known species of bacteria are pathogenic, cause diseases in humans. All the rest just sit around and help us live. There's bacteria in your gut, your intestines, on your skin, in your bloodstream. They all have function. The ones in your gut help us, and intestines help digest food. The ones on your skin help us have nice, shiny skin. And the ones in our bloodstream, well, they help our immune system. However, there is that small bit of bacteria that do cause infections. And back in the day, when antibiotics weren't here, you could prick your finger on a thorn, have one of the bacteria get into your system, and you'd die that night. But in 1928, Sir Alexander Fleming discovered penicillin, the first antibiotic. Now, antibiotics are used today to treat almost all known diseases, which are from bacteria. But there are some drawbacks. Antibiotics don't work on viruses, and influenza, the common flu, is a virus. So, with the sheer use of antibiotics, pathogenic bacteria is developing a resistance. And as this resistance builds, the bacteria can't fight. The antibiotics can't fight the bacteria. One way that pathogenic bacteria or antibiotic-resistant bacteria is able to become so powerful is through passing on their genes, through gene transfer, or horizontal gene transfer, where one bacterium takes a segment of its DNA and passes it on to another bacterium, or through asexual reproduction, where it just makes more of itself. Now, when we have more and more of these antibiotic-resistant bacteria about, superbugs become a real big issue. And one of the worst superbug genuses out there are from the genus Acinetobacter. This multi-drug resistant bacteria is known to cause pneumonia, urinary tract infections, serious blood and wound infections, and you can be carrying it and not even know it. One of the worst species from the genus Acinetobacter is Acinetobacter baumannii, and it is recorded to have a 50 to 60% mortality rate in the hospital environment. You may be asking, what are we supposed to do in such a scary situation where we can't fight these pathogenic bacteria? Well, enter the bacteriophage, or phage for short. The bacteriophage, you can imagine it as a 20-sided die on top of a straw with strings or tails around the head and the end of the tail, or straw. So, in the bacteria's 20-sided die head is its DNA, which is the bane of bacteria. And the fiber-like tails have a special role to play as well. Bacteriophages only attach to the bacteria that it matches. So if it's to come into contact with our human cells, we politely ask them to leave, and they can't do anything. They can't infect us, and they just float along and find another bacteria. So how do bacteriophages work? Well, when they find a bacterium that they match, they attach the bacterium and inject their DNA to it. When they do this, they hijack the bacterium's manufacturing process inside the cell and make more parts of a bacteriophage. And when these parts come together and the bacterium's at its critical mass of holding phages, explodes and releases more phages into the area, repeating the cycle. So the main reason we're not seeing phages used in the United States healthcare is the FDA hasn't approved it yet. But the FDA hasn't approved it yet because they have not conducted any multi-level drug trials, phage trials, and big pharma companies won't put millions into research if the FDA hasn't approved it. So when we face these antibiotic-resistant bacteria, we may be in trouble. So in 2015, Tom here, acquired an infection of Acinetobacter baumannii, and he developed serious lung, blood, and brain infections. All hope seemed to be lost for him, and he was good as dead. But thanks to quick thinking from his doctors and his wife, they decided to go through phage therapy. And after a few days of looking into phages that might bind to Acinetobacter baumannii, they made a cocktail of them and injected them into Tom's bloodstream and infection area because it was that bad. And then they had to wait. And they waited 3 days, and Tom woke up and he survived. His case inspired interest in an international way in doing research on phages. So some of you may be thinking, if bacteria can develop resistance to antibiotics, can't they develop resistance to bacteriophages? Well, you're right about that. But once a bacteria starts to develop a resistance to a phage, it has to give up its resistance to an antibiotic. So we have them in a catch-22. They lose no matter what we do. In any case, we better get used to the idea of calling phages our saving grace, because antibiotic-resistant bacteria is starting to run wild, and the World Health Organization estimates that by 2050 there will be 10 million deaths per year due to antibiotic-resistant bacteria. So next time you wash your hands, next time you get a cold, don't go for the antibiotics. Figure out what it is at first. If it's just the common cold, bundle up, make some chicken soup, and just wait it out. Burn the fever. And as you're sitting there, eating your chicken soup under your nice warm blanket, ponder the question: have I been sanitizing my hands too much? Thank you.